We turn our eyes now to the sky with more incredible images from space thanks to NASA's James Webb Space Telescope.
It's a big universe out there, and NASA's newest telescope is giving us a look at the very beginnings of that universe.
The James Webb Space Telescope, one of the most ambitious and
The James Webb Space Telescope, a marvel of modern engineering and one of humanity's most ambitious scientific instruments, was designed to peer deep into the cosmos and uncover the secrets of the universe. Throughout its mission, it delivered awe-inspiring images and invaluable data. But unexpectedly, a shock announcement reverberated through the scientific community. The United States had shut down the telescope. This abrupt halt came in the wake of a controversial series of observations involving Mercury, our solar system's innermost planet. What began as a routine calibration maneuver quickly evolved into a mystery layered with tension, secrecy, and unsettling implications. The findings from Webb's Mercury observations were unlike anything previously encountered, casting doubt on long-held assumptions and pushing into territory some may have wished had remained unexplored. Mercury, despite its hostile conditions, searing heat during the day, freezing temperatures at night, and intense bombardment by solar radiation, has always intrigued scientists. Its dense structure, unusual orbit, and magnetic field challenge conventional planetary models. Normally, the James Webb Telescope was not designed to observe such a planet due to its proximity to the Sun and the heat risk to Webb's delicate instruments. However, during a calibration phase, following a series of reorientation adjustments, the telescope's gaze was directed toward Mercury. Officially, the goal was to refine imaging techniques for near-solar objects and enhance adaptive optics. But what was detected during that limited observational period triggered a sequence of actions culminating in a full system shutdown. Sources close to the analysis hinted at unexpected anomalies, patterns, and thermal emissions that natural geology could not explain. Webb's instruments, finely tuned to detect faint infrared signals, recorded symmetrical thermal arrangements on Mercury's surface, inconsistent with volcanic activity or tectonic shifts. These geometric thermal emissions appeared to emerge rhythmically from beneath the crust, suggesting patterns of deliberate design rather than random geological phenomena. Spectral readings from specific regions revealed unfamiliar chemical signatures. Reflectivity levels and emitted spectra suggested the presence of exotic materials, some resembling manufactured alloys or crystalline structures more akin to engineered products on Earth than naturally occurring compounds. The placement of these anomalies, linear, hexagonal, and triangular configurations stretching over kilometers, further fueled speculation. These weren't the typical signs of erosion or meteor impacts. They were deeply buried structures, undetectable to the naked eye, but clearly distinguishable through Webb sensors. Normally, such groundbreaking data would enter the peer review process and be shared with the scientific community. Instead, NASA released a subdued statement citing instrument stress from proximity to Mercury and announced the suspension of further observations. This statement was followed by a series of confidential memos, which later surfaced online, pointing to increased scrutiny by defense and intelligence officials, not scientific bodies. Access to Webb's live feed was restricted. Data repositories that once offered open access began removing or marking Mercury-related files as unavailable due to integrity checks. Scientists involved with the Mercury observation team were quietly reassigned or disappeared from public-facing roles. This sudden silence invited a deluge of questions. Why would data from a supposedly inert planet provoke such drastic action? Why shut down the telescope altogether rather than redact specific findings? A popular theory emerged. Mercury may not be as geologically dormant or lifeless as previously believed. Some researchers speculated that Webb had inadvertently uncovered evidence of ancient technology or ongoing activity. If such structures existed, they could point to intelligent intervention, past or present. The discovery would challenge every established model of planetary formation and potentially rewrite history. A planet like Mercury, long assumed too hostile to preserve complex systems, might in fact offer the perfect hiding place. Its extreme environment discourages exploration, and its closeness to the Sun makes it difficult to study using conventional instruments. Webb's infrared capabilities may have been the key that pierced this natural veil. Within weeks of the shutdown, other unrelated space research efforts began encountering strange delays. Requests to observe inner planets faced increased bureaucratic resistance. Meanwhile, international partners in the Webb project, such as the European and Canadian space agencies, voiced quiet concern. Their public responses were cautious, but their internal communications, according to leaks, were far more alarmed. The timing and secrecy surrounding the shutdown led some to suspect that what Webb uncovered extended beyond Mercury, perhaps hinting at a system of planetary-scale infrastructure. Despite a lack of official acknowledgement, speculation intensified. Was Mercury being used as a surveillance node, a storage site, or something more advanced? The implications of dormant or active artificial structures on Mercury were staggering. Theories circulated that Webb's instruments might have triggered a latent system, one that responded to its scans. Observers reported that certain emissions mirrored Webb's scanning sequence, suggesting a form of reactive behavior. Whether intentional or accidental, it raised fears of unintended contact with a forgotten system. The shutdown itself was swift and precise. Webb was placed in standby mode, power was scaled down, and all remote operations were restricted to critical personnel. There was no public farewell, no final press briefing, no handover to secondary teams, just silence. A telescope, once hailed as humanity's eye into the cosmos, had been closed with surgical secrecy. Now, with Webb offline, efforts to verify its findings have fallen to independent astronomers and researchers. But ground-based telescopes lack Webb sensitivity, especially near the sun's glare. The flow of information has been severed. In the days following the shutdown, numerous amateur astronomers tried to trace Webb's last observational path. By comparing its orbital logs and telemetry records with publicly archived data, several groups pinpointed a region near Mercury's equator as the telescope's focus. This area had been previously surveyed by earlier missions like Mariner 10 and Messenger, both of which had noted minor anomalies, magnetic irregularities that were once dismissed as sensor glitches. But in light of Webb's findings, these old data points took on new significance. Around this time, a handful of low-frequency signals were picked up by radio enthusiasts pointing their equipment at Mercury. These pulses were irregular but structured, lacking the random patterns typical of solar noise or planetary interference. Whether these were signals from an ancient system or the byproduct of some unknown natural process remains unclear. However, they were only noticed after Webb's focus on Mercury, and some speculate the telescope may have acted as a trigger. Thermal imaging satellites also began noticing slight shifts in Mercury's heat patterns. At dawn and dusk, localized warming was detected. Subtle, but statistically significant given the planet's thin exosphere and lack of atmospheric insulation.